Hi everyone, I'm Ava. Today we're going to be looking at the AMC 2022 problem set. So problem 1 asks, what is the area of the following logo in square inches? So we can split this into a few familiar shapes that we know. And for example, it gives us this grid, so we can use that to find the area. So for example, the square in the middle has an area of 4. And these shapes along the outside have an area of 0.5 times 3. So eventually we get the area of 4 plus 4 times 1.5, which equals 4 plus 6 equals 10. So the overall area of this shape is 10. And what you do is you basically split this unfamiliar shape into different familiar areas, and using that you can identify like the total area of the logo. Problem 2. There are two operations denoted by the rhombus and the star, and it asks what is the value when we have 5 rhombus 3 and star 6. So what you do here is you just take these numbers and you bring them into the given operations. For example, the first would be 5 squared minus 3 squared, and that this would then equal this 5 rhombus 3 minus 6 squared. And so that equals 16 minus 6 squared is 10 squared equals 100. So the answer is D. Problem 3. When 3 positive integers a, b, c are multiplied together, their product is 100. And suppose that a is less than b is less than c, in how many ways can the numbers be chosen? So for these problems, when they tell us that the product is a certain number, the first step is always to prime factorize this number so we can find the different factors. So that would be 50 and then 25. So finally, it's 2 to the power of 2 times 5 to the power of 2. And since we notice that of the selections, the maximum number of ways that numbers can be chosen is only 4. So we can just go through and then considering that it has to be strictly less than each other, then we can just list out the different combinations of A, B, and C. Anyway, so a strategy here is you start with A, B, and C, right? And then you start A from the smallest possible factor, which is 1. And you go up and you find the next factor is 2. And then you can get it through division. Get 50 through dividing 100 by 2. And so you go like 2, 4, 5, so in an increasing order. And this way you will not like miss out on any numbers. So eventually there are only 4 ways in which the numbers can be chosen. Problem 4. The letter M in the figure below is first reflected over the line Q and then the line P. What is the resulting image? So if you can imagine that it reflects over the line Q, which is this diagonal line, the letter is going to have to be the same as when you rotate it in. Right, so basically you would just like rotate it 90 degrees and it would result in this kind of like lopsided way. And then when you reflect it again over P, which is the x-axis, you just get that number reflected. So eventually the answer is E, and even without needing to know the direct orientation, you could kind of get it. So for this problem, it's just mainly about understanding like reflections of shapes, and then once you know that, it's like relatively simple. Okay, problem 5. Anna and Bella are celebrating their birthdays together. 5 years ago, when Bella turned 6 years old, she received a newborn kitten. Today, the sum of the ages of the 2 children and the kitten are 30 years. How many years older than Bella is Anna? We can convert these sentences into mathematical equations. And that way it would mean that b minus 5, which is Bella's age 5 years ago, equals to 6. And that means that Bella is currently 11 years old. And 5 plus Bella's age plus Anna's age is 30. So that is 16 plus A equals 30, and A equals 14. And so then it asks how many years older is than Bella is Anna. So A minus B equals 3, and the answer is 3. Problem 6. 3 positive integers are equally spaced on a number line. The middle number is 5, and the largest number is 4 times the smallest number. What is the smallest of these 3 numbers? So notice here it says equally spaced, which means you would have like A and then A plus R, A plus 2R, and then so on. So we know the middle number is 15 and that the largest number is 4 times the smallest number. So we can assume that the smallest number is denoted by x, which means the largest number is 4x. And because at the same time they're equally spaced, this means 4x minus 15 equals 15 minus x. And so this is a simple equation. We can just solve this directly. So x equals 6, which is the smallest number of these 3 numbers. Problem 7. When the World Wide Web first became popular in the 1990s, download speeds reached a maximum of about 56 kilobits per second. Approximately how many minutes would the download of a 4.2 megabyte song have taken at that time? And there are 8,000 kilobits in a megabyte. So first, minutes is basically 60 seconds. It is 60 seconds. So when it asks us how many minutes it would have taken, we need to remember to divide the final answer by 60. So to find the speed of something, or like the time, it equals like the distance divided by your rate. And so in this case, distance is how many kilobits there are. And that is 4.2 times 8,000. And the rate, or like the speed in which you're kind of downloading it, is 56. And then finally we multiply the answer by 1 over 60 to get the number of minutes. So notice here that 4.2 is basically 42 times 0.1. So we can first divide the 8 out of 456 to get 1,000 on top and 7 on the bottom. And then divide 4.2 by 7 to get 0.6. So that equals to 600 divided by 60. And the answer is 10 minutes. So this is basically just converting a word problem into an equation and then solving the answer for that. Problem 8. What is the value of this product of these many fractions? So there are a lot of problems that have numbers like 1, 2, 3, and then they increase by certain during an arithmetic equation on top, and on the bottom you have a similar arithmetic equation. And for these problems, especially when they're a product, all you do is you just cancel out 3, 3, and then 4 and 4 here. And so we can go ahead and do that. And so it would go all the way until the 20 on the top is canceled. And when you take the remaining terms out, you get 2 over 21 times 22, which equals 1 over 21 times 11. And 21 over times 11 is 231, so the answer is B. Problem 9. A cup of boiling water is placed to cool in a room whose temperature remains constant at 68 Fahrenheit. Suppose the difference between the temperature of the water and the room temperature is halved every 5 minutes. What is the water temperature in degrees after 15 minutes? So that means you would halve it 3 times. So the current difference right now is 212 minus 68. And by performing some quick calculations, we know that that is 144. So when you have it at 212 right now, next it would be 212 minus 72, which equals 140. Next is 140 minus 36 equals 104. And then finally, 104 minus 18 equals 86. So the answer is B. Problem 10. One sunny day, Ling decided to take a hike in the mountains. She left the house at 8 a.m., drove at a constant speed of 45 miles per hour, and arrived at the hiking trail at 10 a.m. After hiking for 3 hours, Lin drove home at a constant speed of 60 miles per hour. Which of the following graphs best illustrates the distance between Ling's car and her house over the course of her trip? So, when she's hiking equates to no change. So on a graph, that would be just like a straight line. And so that means that for 3 hours of her time, her car is not moving any distance from her house. And so she gets there at 10, and then we can look at all of these graphs and say, okay, well, we can't cross out any of them yet, since all of them are not moving for 3 hours. But then drives at a constant speed of 45 miles per hour, and she drives 2 hours. And so that means that the mountain that she's at is 90 miles away from her house. So then we can cross out B, cross out D, and then C. So now we just have A and E left, and the only difference that they have is the final distance, time she takes to get back home. So to get back home, she has to drive 90 miles at 60 miles per hour, which is 1.5 hours. So this point is 2.5, which is exactly 1.5 hours after 1 hour. So the answer is E. Problem 11. Henry the donkey has a very long piece of pasta. He takes a number of bites of pasta, each time eating 3 inches of pasta from the middle of one piece. In the end, he has 10 pieces of pasta whose total length is 17 inches. How long in inches was the piece of pasta that he started with? So imagine that there is a piece of pasta, and when he takes a bite, he removes 3 inches from the middle. So now he's left with 2 pieces of pasta, and he is missing 3 inches. So basically, one bite does 2 things. First, it gives us plus 1 piece, since he essentially splits 1 piece of pasta into 2 different pieces. The second thing it gives us is minus 3 inches. So now that he has 10 pieces of pasta remaining, it means that he's actually taken 9 bites and subtracted 27 inches of pasta. So the total length of pasta that would have been originally is 27 plus 17 equals to 44. So the answer is D. Problem 12. The arrows on the 2 spinners shown below are spun. Let the number n equals 10 times the number on A and added to the number on spinner B. What is the probability that n is a perfect square number? So essentially this means spinner A is just the tens digit, spinner B is the ones digit. So how many square numbers have a tens digit of 5, 6, 7, 8, and a ones digit of 1, 2, 3, 4? So within these bounds of 60 to 84, you only have 2 square numbers, which is 64 and 81. The total number of numbers you can form is 4 times 4 equals 16. So the probability that you actually spin a square number is 2 over 16, which is 1 over 8. So the final answer is B. This is just a probability problem where you find the total number of possibilities and then how many possibilities are favorable. Problem 13. How many positive integers can fill the blank in the sentence below? Where one positive integer is, let's say this is n more than twice another, and the sum of the 2 numbers is 28. So let's say that this positive integer is x. Okay, so what you get here is x plus n plus 2x equals 28. And so that is 3x plus n equals 28. Within the bounds of 28, the largest possible x that you could have is 9, since 3 times 9 equals to 27. And so that means that x you have from all the way from 1 to 9. And so that is 9 different x's that you can have. And we don't really care about the value of n, since that is like relatively easy to find a number for. You just subtract 28 minus 3x. And so that means that there are only 9 possibilities of these numbers. And so for this problem, essentially what you need to do is you just need to write it out in this equation format, because then it's pretty easy to see the bounds of it. Problem 14. In how many ways can the letters in beekeeper be rearranged so that 2 or more e's do not appear together? So like this problem looks really hard, right? Because it's like a really long word and there's like a lot of letters. But if you actually like counted how many e's there are like there are 5 e's and then 4 other letters. And so if you want them to not be like 2 or more appear together, you have to have e, and there are 4 gaps between, right? So you just place each of the 4 other numbers within them. And so it's kind of just like makes it look very hard, but it's really not that difficult. So then that means that you just have to rearrange these 4 other letters. And to rearrange 4 objects that are all distinct, B, K, P, and R, you just have to use factorial. So 4 factorial equals 4 times 3 times 2 times 1 equals 24. So the answer is just D. Problem 15. Laszlo went online to shop for black pepper and found 30 different black pepper options varying in weight and price. In ounces, what is the weight of the pepper that offers the lowest price per ounce? So to find lowest price per ounce, we want something that is, like ideally, something with the lowest price per ounce would be right here. Which is obviously not appearing on this graph, but what you want is like a rectangle where the width is longer than the height. So we can like observe here, we have a few candidates. So number 1, you have this one here. And the second candidate you have is this one over here. So the price per ounce for this one would be around 4.5 divided by 5, which equates to 9/10. And for the one on the bottom here, it's 2.5 divided by 3 equals 5/6. And so if you want to compare these two, you have 5/6, 9/10 is 50/60 versus 54/60. And so obviously it's very clear that 5/6 is less than 9/10. So the answer here is like the weight of that is 3. So the answer is C. So 4 numbers are written in a row where the average of the first 2 is 21. The average of the middle 2 is 26, and the average of the last 2 is 30. What is the average of the first and last numbers? So we can assume the first number is x, and for the average of the first 2 to be 21, the sum of them needs to be 42. And so this is 42 minus x. So same logic for the next number. It's going to be 52 minus 42 minus x. And so that equals 10 plus x. The last one is 60 minus 10 plus x, which equals 50 minus x. And so the average of the first 2 numbers is 50 minus x plus x divided by 2 equals 25. So the answer is B. N is an even positive integer, and the double factorial notation n double factorial represents the product of all the even integers from 2 to n. For example, 8 double factorial equals 2 times 4 times 6 times 8. And what is the units digit of the following sum? So all the way up from 10 double factorial to 2022 double factorial, these numbers are all something times 10 times etc. And so that means that the units digit of all of these is always going to be 0. And since the only number we care about is the units digit, so we can assume that all of these numbers, you just add up to 0. And our job here is then we only have to add up 2 double factorial to 8 double factorial. So the unit digit of 2 double factorial is just 2, of 4 is 8, and then the next one is 8 as well. And the last one is 4. So that equals 10 plus 12 equals 22. So the units digit is 2. Problem 18. The midpoint of 4 sides of a rectangle are these 4 different points. What is the area of the rectangle? So the midpoint of a rectangle, midpoint of the sides of a rectangle, they look like this. And if we connect all of them up and split this rectangle down the middle, we notice that these midpoints, they add up to half of the area. And so all we have to do here in this case is just find the area within these midpoints of the 4 sides of the rectangle, and then multiply that area by 2. So for the sake of understanding this, we can draw it like this. So first you have -3, 0. And then you have 2 here. So next we can connect up all of these midpoints. So the height here is 4 and the base here is 5. So the area of this parallelogram is 5 times 4 equals 20. So the total area of the rectangle is 20 times 2 equals 40. So the answer is C. Problem 19. Mr. Ramos gave a test to his class of 20 students, and the dot plot below shows a distribution of test scores. Later, Mr. Ramos discovers that there was a scoring error on one of the problems, and he regraded the test, awarding some of the students 5 extra points, which increased the median test score to 85. What is the minimum number of students who received extra points? Okay, so here we have our dot plot. And right now we know that before he regraded his test, there were 2 students in the 65 area with 65 points and 2 students with 70 points. So we can just tally up how many students, like the number of students in each of these score categories. And currently, we know that to find the median, we need to find the 10th and the 11th student, and then find the average of their scores. So we can tally this up right now. So these two added up is 4, this is 8, and then this is 13. So we know that the 10th and the 11th student are somewhere in this pile here, which makes the median equals to 80. And so that means that we know that for students with points less than or equal to 75, there are 8 students. And for the median to be 85, there can only be 9 students that have a point of less than or equal to 80. And so that means that we have to cut down 4 students from the pile of 80 points. So that means moving 4 students over here into the pile of 85 points, and in that way our median will be 85. And so the number of students that have an increase in 5 points, the minimum needs to be 4. So basically, for this problem, you just need to understand the definition of a median and then apply that to the situation and find, okay, so how many students need to be within 80 points and how many students need to be within 85 points, and so on. Problem 20. The grid below is to be filled with integers in such a way that the sum of the numbers in each row and the sum of the numbers in each column are the same. So 4 numbers are missing and the number x in the lower left corner is larger than all the other 3 missing numbers. What is the smallest possible value of x? So with the smallest possible value of x, it means that all three numbers are, it means that the three numbers are close as possible. So notice here that it already tells us that the sum of the rows and the columns are 12. So we can first just like test out some numbers. For example, if this was 3, this would have to be 9. This would have to be 0. And x would be 4. Now obviously that isn't the correct answer. Now we can first observe this row here. There's already a very large number, 8 here. And so that means the maximum number that x could be right now, if this number here was larger than or equal to 0, if it was non-negative, the largest number x can be is 4. However, then on this row, there's a very small number here. So when x is only 4, it means that this number here would be extremely large, and it would be a lot larger than x. And so it looks like there's no solution here, but if you come back up to the problem description, it tells us that the grid below is full of integers, and that means integers can be negative. That means that this number here, it must be negative, because when it is negative, x is able to become a very big number, and that would allow it to be the largest number than the other three numbers. So you can do some trial and error. First, if this number in the middle is -2, this would be 6, and that would be 8. So that is still too large. So we can try -4. And now it's 6. And this number here is 7. So this is the final answer, and that means the smallest possible number of 8 is 8. Since there already is like 6, 7, 8. And so there's no possible number that is smaller than 8 and x. Problem 21. Steph scored 15 baskets out of 20 attempts in the first half of the game, and 10 baskets out of 10 attempts in the second half. Candace took 12 attempts in the first half and 18 attempts in the second half. In each half, Steph scored a higher percentage of baskets than Candace. Surprisingly, they ended with the same overall percentage of baskets scored. How many more baskets did Candace score in the second half than in the first? So notice that they both took a total of 30 attempts. And that means that if the first half is x and the second half is y, x plus y must also equal 15 plus 10, which is 25. It also tells us that within each of the halves, Steph always scores a higher percentage. So that means that x over 12 is less than 15 over 20, which equals 3 over 4. And y over 18 is less than 1. So this means that x is less than 9. And since x plus y need to add up to 25, and we also want to ensure that y is less than 18, we want to ensure that x here is as large as possible. And so the largest possible value of x is 8, and this means y equals 17. And 17 is also at the very edge, and it's also less than 18. So we know that Candace scored 17 minus 8 equals 9 more baskets in the second half. So the answer is C. Problem 22. A bus takes 2 minutes to drive from one stop to the next and waits 1 minute at each stop to let passengers board. Zia takes 5 minutes to walk from one bus stop to the next. And as she reaches a bus stop, if the bus is at the previous stop or has already left the previous stop, then she will wait for the bus. Otherwise, she will start walking toward the next stop. Suppose the bus and Zia start at the same time towards the library, with the bus 3 stops behind. After how many minutes will Zia board the bus? So what this problem is basically meaning is like if the bus is here or it's like on the way here, she's gonna wait. Otherwise, she's not gonna wait. So she starts at bus stop 3, and the bus starts at 0. And if you look at the total, like the answers, the largest possible time that she would potentially be waiting for is only 23. So we can safely just draw a table and then like simulate where each of these people would be at within a certain time. So at time 5, Zia has just walked to bus stop 4, and the bus has traveled to this stop within 3 minutes, and then arrived at this stop, which is bus stop 2. However, it's currently waiting for passengers. At time 10, Zia is at bus stop 5. And the bus has waited 1 minute and then walked over here in 3 minutes. And so that's 4 minutes. And then they have driven about here, which is halfway. So they're in the middle of 3 to 4. At time 15, Zia is at bus stop 6. And the bus has went from around here and taken 1 minute to drive here, and then waited another minute, so that's 2 minutes. And then they drove here within 3 minutes and finished waiting. So they're at bus stop 5 and they're about to leave. So I noticed that here, the bus has basically caught up to Zia already, and it is at the previous stop. So Zia is going to wait for the bus to arrive and then board. So that is 15 minutes, and then plus an additional 2 minutes of waiting for the bus to arrive at her stop. So then that is 17 minutes, and the answer is A. So for this problem, since the numbers that it gives us are relatively small, we can just draw a table and simulate what time and what location the bus and Zia will be at. Problem 23. A triangle or a square is placed in each of the 9 squares in a 3 by 3 grid. Shown below is a sample configuration with 3 triangles in a line. How many configurations will have 3 triangles in a line and 3 squares in a line? So there's 2 ways that you could have these lines. Either you have them vertically, like this way, or you have them horizontally. And so for each of these ways, you have to consider that you have 2 lines here. For example, let's say we have these 2. The first 2 columns are our triangle line and our square line and our circle line. And then you have a 3rd column which is randomly distributed. However, at the same time, in this randomly distributed way, you could still have it just coincidentally end up in 3 triangles or 3 circles. So in that case, you have to subtract a number of cases to ensure you don't have overlap between different ways. So first you would multiply everything by 2, since it could either be horizontal or it could be vertical. So then you have first, you choose which line is going to be the random line. And so that means you have 3 choices of that. Then you choose which of the 2 other lines are going to be the circle or the triangle. So that's 2 ways. And then you randomly you randomize the 3rd line. And to subtract the number of overlapping ways, you subtract 2, which is either triangle or circle, and you multiply that by 6. And the reason you have 6 is because there are 6 different lines in which the randomized line could be already seen before. So that's 3 ways vertically and then 3 ways horizontally. So we can calculate this out as 2 times 6 times 8 minus 12 equals 96 minus 12 equals 84. So the answer is D, 84. So actually this is a counting problem, but there's a lot of ways in which you could count this out. So there could be other ways that you think about it, but this is just one possible way. Okay, problem 24. The figure below shows a polygon A, B, C, D, E, F, G, H consisting of rectangles and right triangles. When cut out and folded along the dotted line, the polygon forms a triangular prism. Suppose AH equals EF equals 8 and GH equals 14. What is the volume of the prism? So for this problem, what you have to do is you have to find the side lengths and then use that to find the volume. So first I'm just gonna draw this out and what the prism would look like if you actually formed it. Okay, so if you actually drew out what this would look like when it was expanded, it would look like this shape. So here, it would be 8, since you have this and you parallel it across. Okay, so then notice this rectangle here to tell us that EF equals 8. And this is connected to the short side of the triangle, and that would be this side. So imagine that this rectangle, it is like flipped over, and it forms into this rectangle, which is the base. So that means that EF here, it would be 8 here. And that is the same line, or it's like parallel to the line here. So that means that HJ equals 8 and JG equals 6. So you have here the triangle sides, and you also have the depth of this triangular prism. So with these three sides, we can already calculate the volume of this prism equals 8 times 6 divided by 2 times 8. And this equals 24 times 8, which is 192. And so the final answer is C. Okay, a cricket randomly hops between 4 leaves, on each turn hopping to one of the other 3 leaves with equal probability. After 4 hops, what is the probability that the cricket has returned to the leaf where it originally started? So let's label these leaves 1, 2, 3, 4. If it starts on the first leaf and it hops 4 times, second time it hops somewhere else, and then third time, and then on the fourth hop, it hops to 1. However, notice that you cannot hop from leaf 1 to leaf 1. So that means that on the third hop, it must be hopping to either 2, 3, or 4. And so if we go backwards from the final destination that we want is 1, the last stop that it hops must be 2, 3, or 4. And for the sake of calculating later on, so we need to calculate the probability that it comes from 1, like the previous leaf was 1, and the probability that the previous leaf was 2, 3, or 4 separately. And each of these could also come from 2, 3, or 4. And then the first leaf is 1. And so the reason that we have 2 branches here is because if you're coming from 2, 3, or 4 to 2, 3, or 4, you have 2 different leaves that you can jump to. If you come from 1, you have 3 different leaves that you can jump from. So then this means that the final answer you have is 3, since on the first hop here, you have 3 leaves you can hop to. The next hop is, assuming that you're hopping to 1, then you have 1 location you can hop to. And from this, you have 3 locations you can hop to, and then 1 in the end. The total number of hops, like the total number of ways you can jump around is 3 to the power of 4, since you have 4 different hops, and then 3 other leaves you can hop to in every hop. And then the second way is 3 times 2 times 2 times 1, divided by 3 to the power of 4. And so you can cross out some numbers first. And then you get 3 plus 4 over 3 to the power of 3, which is 7 over 27. So the final answer is E, 27 over 27. Okay, so these are all of the problems for the AIMC 2022 set. And the last one was just a probability problem, where we just split up into a few cases. And if you have any questions about especially the last few problems, feel free to leave them down in the comments, and I'll try and get to them. Bye bye.